Hey everybody, we're going to take a look at the beginning of modular arithmetic, and specifically we're going to use tables. And I encourage you to use tables, particularly as you're getting used to this. You may be like, oh, I can figure this out on my own, but the tables are really helpful to look for patterns. And so what I have here, I'm using Z12 or Mod 12 as we call it. And so I have a table here set up with the addition. So if you'll notice across the top, so I'm basically adding any one of these numbers, 0 through 11, to any one of these numbers. So remember when we're talking about mod 12, what this really is referring to is the remainder of a number after dividing by 12. So that's why it goes from 0 to 11, because if I divide 12 by 12, that's 1 with the remainder 0. So 12 actually corresponds to 0, not 12. Anyway, so the reason for looking at these tables like this is, like I said, you can see there's some symmetry here. Like down this diagonal this way, you'll see the 11s, and in fact the diagonals going back and forth in this direction, all the way back and forth, all have the same numbers in them. And there's other things that show up in other tables as well. And I use Z12 because it's not an example that you're using elsewhere. Okay, so the first question I want to look at here is this notion of does the congruence class of 3 have an additive inverse in Z12? So you might remember what an additive inverse is. An additive inverse essentially is a number that we add to another number and the sum is 0. In other words, by adding a number and its additive inverse together, we get what's called the additive identity. And 0 is the additive identity in this case. So we could write this as an equation like this, where we would put 3, the congruence class 3 plus congruence class of whatever x is equals 0, and this is all in mod 12. Okay? So what we're really looking for is we're going to look across our table here. So if I look at the row 3, and I'm going to go across and ask myself, oh, here's 0. So something does equal 0. What is that? That's 9. So what that essentially means is that the congruence class of 3 plus the congruence class of 9 is, oh, I forgot my third line there, is equivalent to or congruent to 0 mod 12. So that's one way we can look at this. And so we can look across this and, for instance, what's 9 or what's 6 plus 7? So I come over here to 6, come over here to 7, and I notice that 6 plus 7 in mod 12 is going to be 1. Or if I want 9 plus 4, come down here to 9, go over to 4, that's also 1. Well, what about 4 plus 11? So I come over here to 4, I come over to 11, and I notice that the answer there is going to be the congruence class 3. Okay, so the only sets of numbers we really need here are from 0 to 11, and we can do all of our addition in there. So another question we might ask while we're looking at this is there any number that does not have an additive inverse? So what we're really looking for is we're looking for any rows that are not going to have a 0 in it, because then what we're saying is that particular number, there's nothing we can add to it that will produce 0. So as I look here, clearly in the first row we have 0 as the first one, and in the second one, if I come all the way to the end, but then here's where our symmetry comes in. So notice that the diagonal puts a 0 in every single row after that. So we can answer that question in the negative. In other words, there are no numbers that do not have additive inverses. If we say that in the positive, then what we're really saying is we're saying that all the elements in Z12 or mod 12 have an additive inverse. Okay. So I would encourage you to build the tables. It's going to be with addition and things like addition, subtraction, division, or multiplication. Probably fairly straightforward. It's good practice, though. Next module will actually be looking at exponentiation, because that's going to be helpful for when we start to get into the RSA encryption system. Anyways, look at the further videos to see some more about multiplication next.